Storing secrets safely is a big deal. You might think that it's okay to keep passwords, access tokens, and sensitive information in a private Git repo, but I'm here to tell you it's not. Really, it's not. While it might seem safe to keep this information in your private Git repo, it's still susceptible to exposing this sensitive information. Let's say, for instance, you clone your repo and you lose this device, and all your secrets are on that local disk. Or maybe it's not even your laptop that gets compromised, it's someone else's on your team, and now all your secrets are compromised too. Or, in the rare event that GitHub, GitLab, or any other source control provider has a breach or data leak, your secrets can then be accessed by anyone who cloned the repo. Or maybe the breach isn't even against Git itself. Maybe it's during CI. Because remember, CI also clones your repo too. Because of all of this, I've decided to start encrypting all of my sensitive information that I keep in repos, public or private, using SOPS from Mozilla. You know, the makers of Firefox. SOPS is an editor of encrypted files. It's great for encrypting Kubernetes secrets, but can even be used for plain old YAML, JSON, ENV, INI files, and even binary formats. SOPS doesn't actually do the encryption itself. It relies on other encryption technologies like AWS KMS, PGP, Age, HashiCorp Vault, Azure Key Vault, etc. Now, all of these have their pros and cons. Some are offered by cloud providers, and some can be self-hosted but are complicated to set up. And some, like PGP, are considered deprecated. Because of all of these challenges, I highly recommend using the new, simple, modern, and secure encryption tool called Age. Yes, I know it looks like Age, but the maintainer says it's pronounced like Age. It's built on Go and features small explicit keys, no config options, and a Unix-like composability. It will all make sense here in a second. But first, a huge thanks to our sponsor, Datree, for making today's video possible. How many times have you applied a Kubernetes configuration only to realize later that it was misconfigured, not configured according to best practices, or just plain wrong? These types of misconfigurations can create engineering churn and possibly even downtime. That's where Datree can help. Datree is an open source tool that prevents Kubernetes misconfigurations from ever reaching your production Kubernetes cluster. It does this by scanning Kubernetes objects against a centrally managed policy. This policy comes with Kubernetes best practices built in, but is flexible enough so that teams can customize the policy according to their organization's needs. And Datree isn't a simple YAML linter. Along with YAML validation, it also does schema validation, as well as checking against your configured policy. Datree also comes with a fancy dashboard that is backed by great documentation to help you fix errors fast. It installs in seconds and can be run from a CLI, from kube control, in your CI and CD pipeline, and even as a Kubernetes admission hook that can intercept and test Kubernetes manifests, even in this last mile. The bottom line is that Datree can help prevent Kubernetes misconfigurations from happening in the first place. So see the link in the description to download Datree and help empower your engineers today. To get started with SOPS, we're going to need to set up a few things. We'll need to install SOPS, install Age, and then we'll need to generate some encryption keys, and then we can encrypt to our heart's content. SOPS is compatible with Windows, Mac, and Linux, but I'm going to use Windows plus WSL 2, but that's just as easy. First, we'll need to install SOPS, and we can do that from their GitHub repo. And once you get there, be sure and star it. And then we'll go into the releases section. From here, we'll see released versions. And we'll see different builds for different architecture and different platforms. So since I'm on WSL with Ubuntu, I'm gonna copy the link to this download here, this Debian package, and then I'm going to run this command right here, which is just a wget to download the file. And a quick note, all of these commands are in my documentation, and you can find that link in the description below. So we'll do a wget to get this file, then we'll do an ls, and we should see that file. Then we're gonna use our package manager to install this file. Then, once it's installed, we want to remove the file that we just downloaded. Then we can test to make sure it's working by running a sops-v. This should return the version. Next, we need Age. Remember, it looks like Age. And once you get to their Git repo, be sure to start too. And then if you scroll down, you'll actually see different ways to install this. But we're going to do it the same way we just did it before. We're just going to do a wget on the releases page. And I'm going to copy the link to my clipboard. And then I'm going to run a wget and download that file. I'm actually going to rename it too. You can see in there just to make these commands a little bit easier. But we should download that file. If we do an ls, we see that file right there, gzipped. So let's untar it. We should do an ls. And now we see we have a folder. And then we're gonna move this binary to user local bin. And then we're also going to move the keygen or the key generator binary to our bin folder as well. Then again, let's clean up that folder and clean up that archive. And if we do an ls, it's not there anymore. Now we should be able to test AGE. So AGE version 1.0 and test the keygen too, 1.0, looking good. So now that we have AGE installed, remember that does the encryption, we need to create a public and a private key. You can do this by simply running age-keygen-o and then output it to key.txt. So now we just created our public and our private key. It's showing the public key because the private key is a secret. So keep that secret, don't commit it to your repo, put it somewhere very, very safe, not on the internet, unless you encrypt it and put it there. But that might be kind of inception if you need it someday. But if we cat that out, we can see it. You can see my key. This one's just for testing. I wouldn't show this otherwise. But we can see we have a public key and then our private key or our AGE secret key right there. Doing good. So now let's move this into a safe place. Let's make a directory in our home directory for .sops. And then let's move our key file that we have in this folder to that folder. And now we should be able to cat out that file again just to make sure that it is in the right location. So that's good. Now we need to add an environment variable. And we're doing this so that we don't have to keep copying and pasting our key in when we encrypt files. So let's add an environment variable really quick. So if you're running ZSH, like I do, or Z-Shell, you're gonna edit your ZSH-RC or your config file. If you're running bash, you'll wanna do your bash RC. Either will work, but you'll want to make sure it's the shell that you're using. So I use Z-Shell, so we're going to edit this. And at the very end of this file, let's add this. So we're going to export this variable, sops AGE key file, and we're going to point it to our home directory, to that sops folder we just created, to the key or public and private key pair. That's the .txt file. Once you have that there, you'll want to save that, and then we'll close out. And then you want to source your shell, or basically refresh your shell with your config. So if you're running ZSH, it's going to be source and then the path to your ZSH-RC. And then if you're running bash, it's the same thing, but again, bash RC instead. So now we can start encrypting files. Now, there's a few ways to do this. You can do it from the CLI and only use the CLI commands. You can actually use your favorite editor and pipe the output into the editor and save it and then close it out. Or you can add extensions, and we'll get into that in a little bit because it's super cool. But we're gonna do it from the command line, and then I'll show you how to do it in the UI here in a little bit. So we're gonna start with everyone's favorite markup language named YAML and edit some YAML files. Now, these YAML files can be Kubernetes secrets, Helm values, or even just plain old YAML files. It'll work on all of them. So let's see, let's create a secret really quick. So let's create a Kubernetes secret. So I'm gonna do nano secret.yaml. And in here, I'm going to paste a pretty typical secret. As you can see, this is a Kubernetes secret. It's using the Kubernetes API. It's the kind of secret. And for metadata, this is the name called MySQL secret in the namespace of default. And then you'll see string data. So this is the key that has all of my secrets. And you can see my MySQL user here is root. And let's go a little bit higher, not just plain old root, super root. So my MySQL user is super root. And then my password is some secret password. Now, if we save this and cat it out, obviously it's going to look the same. We haven't encrypted it yet. And so here's how we encrypt it. Very simple. We encrypt it with this command. Now, I know this command looks long and scary, but once you copy and paste it once, you'll use it all the time. And like I said, we're gonna do it here in VSCode in the UI here in a second. Well, let's talk about what this is doing. So this is actually calling SOPS. We're telling it to encrypt it. We're telling it to use AGE, which is the encryption format. And then we're saying, hey, go get the variable called SOPS AGE key file, and then cat that out, and then grep that for the public key, and then use the encrypted regex and look for string data, the key we just mentioned earlier, and then we're going to encrypt in place and then pass in the file. Now, I know that's a lot going on, and like I said, we'll use the UI here in a little bit, but most of this will be the same when you're encrypting YAML files. The things that will change, possibly, is your string data, so which key do we want to look for to encrypt keys, and the path to the file. And regex, I'm not the greatest at regex or regex, however you want to pronounce it. I always feel like if you have one problem and you solve it with regex, now you have two problems. Nothing against regex, it's all me. And regex a little bit. Anyway, so let's encrypt this file. So let's encrypt it. And if we look and we cat this secret file out now, we can see it looks encrypted. So let's open this in VSCode so it looks a little bit better. So here's that secret that we just encrypted. We can see, we still see the name of the secret, which is nice, and we see the namespace. But if you look at string data now, the user is now encrypted and the password is now encrypted. And then you see a lot of other keys that SOPS will use to be able to decrypt this file. You'll see timestamps and date modified. None of that's super important. The recipient's kind of important, but that matches my public key. But other than that, you can see that this is totally encrypted. And no one can decrypt this unless they have your private key. And this is now safe to commit to a Git repo, as long as you keep your private key safe. So pretty cool. So let's decrypt it. Let's go the other way and decrypt this file. And that's as simple as running the same exact thing we just ran, but change this to decrypt. And if we go back to our file now, we can see it's now decrypted, so full circle. And we can see that our string data is back. We have our MySQL user called superroot and our password's back. So pretty awesome, pretty awesome. So I mentioned this is a Kubernetes secret, as you can see, could be plain YAML, but what if you want to encrypt this on the fly and apply it to your Kubernetes cluster? Super easy. First, let's encrypt this file. So run the same command we did, but with encrypt. We go back to our file and we see it's encrypted. So let's say you have this committed to your repo, but you want to apply the secret to Kubernetes. Well, there's two different ways you can do it. First, we can decrypt this on the fly and apply it to a Kubernetes cluster. That's what we're going to do. Secondly, if you want to automate this, you can actually have a decryption or a SOPS controller running inside of your Kubernetes cluster with your key that automatically decrypts these secrets and keeps them decrypted so that your services or Kubernetes can use them. We're not going to do that. It's a little more complicated, but if you're already using something like GitOps with Flux, you can easily install that controller so that you can decrypt your secrets on the fly, and then you don't have to do what we're going to do right here. I'll leave a link in the description if you're interested, and if you followed my Flux tutorial, you can just pick up and install SOPS there and continue forward. So let's actually decrypt this on the fly and apply it to Kubernetes. So to decrypt this on the fly and apply it to Kubernetes, we're going to run our decrypt command. So this all looks the same. We're basically saying decrypt this file, but right here we're saying, hey, let's pipe this out to kube control and apply the output to it. Pretty cool, pretty cool. So if we do that now, this will go and apply it to Kubernetes. And you can see that, hey, secret, MySQL secret was created. And if we want to check this secret in our Kubernetes cluster, I'll say kube controller k-describe secrets, MySQL secret. I better change this to kubectl because you might not have an alias, but kubectl or kube control describe secrets, my secret. So we'll run this command and we can see we have our secret there, but this is actually base 64 encoded. So let's actually get that secret and pipe it to JSON and look at the path called data. And if we look at that path called data, we can see we have two keys, our password and our user, but these are base 64 encoded. And if we wanna now look at the key of MySQL password, see what we're doing there? Data.MySQL password and pipe it to base 64 and decode it, we see our super secret password. And if we wanted to see the username, we would just change this to the other key that we encrypted, user. You could see it's superroot. So we've done a lot of this in CLI, and I'll admit I use the CLI, but every now and then I have to use a UI just to check and verify some of my keys. So we can do this really easily using VS Code. So there's actually an extension for VS Code for SOPs. If we look for it in their extension marketplace, we can see two of them, one called SOPs Beta and one called just SOPs. I realized after playing around that SOPs Beta is the one that supports both SOPs and AGE together. And so that's the one you'll need to install if you're using AGE like we are for encryption. I already have this installed, but let's install it again as if I didn't. So be sure to install the beta version. So I'm going to install using WSL Ubuntu, and that will install it. Then once we have it installed, if we open the file called secret.yaml, you see that jump really quick. And look, we have our decrypted file right here. You can see what it did. It basically created a .file, .decrypted, tilde, secret.yaml, and gave us the decrypted value right here. But look, you can see our secret is still here. It didn't touch that. So pretty cool. It's a little bit jarring, but you get used to it. So what I usually do is totally click off either, and then click back on, and there it is again. So really cool. So the other cool thing is we can actually update this here in the UI. So if I wanted to add some more characters to this, I'll add some pounds or hashtags, depending on which generation you're from. And let's save this. And then if we go back to our secret.yaml, we're not really sure if it added it because it's encrypted. So like I said, let's click off really quick, click back to our secret.yaml. It will then decrypt this file, and you can see it added this. So you can do this all in VS Code. One word of wisdom is what I would probably do is add this file name to your git ignore. You don't want to commit this file. This will undo everything we've been doing. So I would add either a wildcard for decrypted or just add the file itself. And so that will ensure that as you commit your secrets and commit your code, it won't actually commit this decrypted file. It would be kind of hard to do because as soon as you lose focus, you can see that it goes away, but it's better safe than sorry. Okay, so let's keep going. Let's encrypt some more stuff. Let's encrypt some more stuff that we usually use. What are some things we use? Well, we use .env files a lot. Use them for Docker, use them for code, use them a lot. And they're usually in your git ignore, and you have to create them every time, and you have to share them with teams, and it gets really inconvenient. I mean, security shouldn't be convenient, but at the same time, the ways of sharing these secrets ends up making a lot of these secrets insecure. So if you just encrypt them and share them, it's a lot better than yelling the password across the room, DMing it to someone on Twitter. This keeps it all safe in your repo. So if we look at this .env file, it's pretty typical. Same example, but with a .env. So we have variable and we have key. So MySQL user, super root. Then we have another variable, or it could be our MySQL password, like we had in the other case. And then here is our super secret password. So we can encrypt these files too, just like I mentioned earlier. So let's do that in the terminal. So in our terminal, very similar, same command all the way to the end, except for we're gonna pass in a -i and then the file type. So the input is going to be a file type. Now notice we're not doing encrypt in place and everything. That's because if you use certain file types, SOPs will detect them, look for key value pairs, and automatically encrypt them. So it knows we're using a .env file. So let's encrypt this .env file. Helps if I put in the right file. So we encrypt that, go back and look at our .env file. Here it is, and it's encrypted. And these files also work with that extension too. So let's decrypt that file. We go here, we see our decrypted file right here in VS Code. We can make the same changes we did before, add hashtags. I'll act like I'm a little younger. We'll add hashtags, then we'll go off this file, then we'll go back. We can see it added them. That's actually, we would have to quote this because in a .env, hashtags are actually comments, but you get the picture. And again, like with this file too, like I said, we'll have to add this to our git ignore file so that we don't accidentally commit it. But you can see here, it's covered with that wildcard above. I think that's how you wildcard. Correct me if I'm wrong in the comments. Pretty awesome. We did YAML files, Kubernetes secrets, .envs. Can you guess what else we can do looking at the examples? Let's go for JSON. So everyone's favorite object notation in JavaScript, JSON. Let's do the same thing. So if we look at our secret.json, you could see very similar. MySQL user in camel case, and then our super root username, and then password, which is our password with this super secret password. And it works exactly the same. Let's do it from CLI. Let's encrypt this using the same command almost, but let's change our file format. Let's say we're using a secret.json. Again, we're saying the input is a secret.json. It will auto-detect this file, look for keys and encrypt them. So we just encrypted the file. Let's take a look in VS Code. We look in VS Code and here it is encrypted. And again, since we installed that extension, if we click off, click back on, it just decrypted it. And we can add some more values to this password, save it. You see it get encrypted down there. Click off, click back on, and we could see it added those. And again, I'm going to add this file as well to my git ignore. I know this is belt and suspenders here, adding a wildcard plus all the extension, but I did it both ways just in case you want to try it out. Next up, what's another one? INI files or INI files. Let's check those out. So if we check out our INI file, this is just a generic INI file. We're saying, hey, in this header for a database, we have a user whose value is super root, and then we have a password that is equal to our super secret password. We can do the same thing we've been doing. Go back to the terminal, change your extension to .ini, hit enter. It detected the extension automatically because it has support for INIs. So let's check out our file. And if we check it out, we can see it's encrypted. Well, we clicked off, let's click back on. It's encrypted with our values. And you saw that VS Code now with that extension also supports this. So if we click on it again, we add some more values here, and we save it, we can see the encryption happening down there. And then if we click off, click back on, we can see it was updated. Pretty cool, pretty cool. And again, with this one too, we're going to add this one. If I can actually, you'll run into this sometime. Get on there, there we go. We can actually copy and paste this name, add this to our git ignore, belt and suspenders for both, so that these don't get committed. Another thing I learned from doing this is that you can just encrypt any file you want. You can encrypt binary files, text files, whatever type of file you want. You can encrypt it. It supports it, which is pretty cool. Let's say, for instance, you have a secret in your SQL file. You would never put secrets or passwords in SQL files. I know you guys wouldn't do it, but if you did, and you put something secret in here, like a username of Robert. And if you've never seen this XKCD comic, you should look it up, but this is the whole Bobby tables. But just say that Bobby or Robert is a secret and we wanted to encrypt this. With SOPS, we can only encrypt parts of files for certain file types. Now, it doesn't support SQL out of the box. We can't pass in some magical regex and have it replace a secret in place. But we can encrypt this whole entire file, like you'll see here. So say, for instance, we put a password inside of the SQL. Let's just say that Robert was actually a secret and we didn't want anyone know this student's name. We could just encrypt the whole entire file. So we'll run almost the same exact command we've been running this whole entire time, but at the end, we're gonna say encrypt in place, and then we're gonna pass the SQL file to it. So if we run that, it just got encrypted. And if we look at the values now, it doesn't look anything like SQL. It's actually JSON now, but this is an encrypted file. And because it's an encrypted file, this VS Code extension doesn't actually support decrypting this. I get it, because who knows what it could be, but it doesn't support decrypting it. But we know the command to decrypt it. Let's go back to the terminal, run the same command, except we're gonna pass in the decrypt flag up there, and we decrypt it. We go back, and it's decrypted. Keeping your secrets safe inside of your Git repo, whether it's public or private, should be a top priority. I'll be the first to admit that I've pushed up code that had secrets in it, thinking that a private repo was protection enough. But that was mainly because I really didn't understand what my options were. I didn't understand encryption, and I didn't have a tool like SOPS and Age to do this easily. And I think that's part of the challenge of all of this, is that people don't understand what options they have. I hope that through this tutorial, you see how easy it is to encrypt your files so that you can commit them to your Git repo, whether it be public or private. And remember, if you found anything in this video helpful, Don't forget to like and subscribe. Thanks for watching.
I've been still doing the 100 days of HomeLab. I think I'm on day 105. I don't know if I'm gonna stop. I don't know. I don't think I'll ever stop doing it unless I go on vacation or if I forget to tweet, then I'll break my streak. But I'm gonna keep my streak up as long as I possibly can. And it's also I realized that it's also fun to just like use this hashtag to connect with other people who are doing things in HomeLab. 100 days of HomeLab or not. So it's actually super nice for that. And it just gives me things to talk about or think about or people to connect with. So I'm going to keep doing it.